33, 35 total characters in string after transformations 1. So for this problem, we are giving a string s and an integer t representing the number of transformations to perform. In one transformation, every character in S is replaced according to the following rules. So the first rule is that if the character is Z, replace it with the string AB. So if we find a character with Z, we're going to replace it with AB. And secondly, we're going to replace it with the next character in the alphabet. So for example, if it is A, we're going to replace it with B. If it is B, we're going to replace it with C, and so on. We're going to return the length of the resulting string after exactly k transformations, so the answer is going to be modular on this number. Let's just check the first example. After the first example, we might think about a way to solve the problem. So, like A, B, C, Y, and Y. So for the first transformation, we're going to get like B, C, D, because this is going to be B, C, D, Z, and Z. Yeah, it will always go to the next character in alphabet, so it's going to be B, C, D, Z, Z. And for the second transformation, because for this B, C, D, we're going to have C, D, E, and for this Z, it's going to become A, B, and another Z, it's going to become A, B. Yeah, so this is going to be the final string, so we're going to return the length, which is going to be 7. So we just need to return the length of the final string, and instead of return the final string. If we are going to return the final string, definitely it's going to be difficult. But if we are going to return the length of the final string, so it's going to be easy. So basically, we're going to use the dynamic programming to solve the problem. Yeah. So the idea is that for each of the character, if it is a Z, definitely we can turn it into AB. If it is a Z, we're going to turn it into AB. So we just need to count how many Z, or how many A, how many B, but most importantly, we just need to count how many Z. So this means we're going to use a counter. And we're going to use the counter to find the final answer. So we're going to prepare a counter array. So I'm going to set it as F. So this is going to be a counter array. And then we're going to use this array as a dynamic programming array to solve the problem. Because inside this array, basically it means it is the characters like A, B until Z. And we just need to check how many Z. So for example, if t equals to 1, for this transformation, if the Z is 1, so the number of Z is 1, so what's going to be the final length? So if the length of this string is L, so the final length is going to be L plus 1. So if we have the frequency of the Z is going to be 2, so what is going to be the final length? It's going to be L plus 2. Yeah, so this is for t equal to 1. But what about t equal to 2? And we just need to check after this Z, how many A's and how many B's. Yeah, so this means we're going to use the dynamic programming. Yeah, because for something like A, B, C, until something to Z. So for each of the transformation, A gonna go to B, B gonna go to C, and Z gonna go to A and B. Yeah, so this means we're gonna use the transformation. So the transformation is going to be A to B, B to C, and Z to AB. So this is going to be the transformation of the dynamic programming. We just need to finish such kind of a transformation formula to solve the problem. Yeah. Now let's just do some preparations. So the mod is going to be 10 to the power of 9 plus 7. And I also need to have a final result going to be the length of the string. Because it's going to become bigger and bigger, but from the beginning, it's going to be the length of the string. It's going to be 5 in example 1. Now, what are we going to do? We're going to just check all the characters one by one. So for C in S, F odd C minus odd A, gonna plus equal to 1. Now we finish our array, and next we're going to use this F array to finish the final part. So for anything inside the transformation t, because t is 10 to the power 5, so this means it is okay. And for here, this is the time complexity from here is 10 to the power 5, because we just need to check the length of the string. And here we just need to check t. T is also 10 to the power 5. This means we can solve it by using O(n) time. So n is 10 to the power 5. So for each of the transformation, what are we going to do? We're going to update the final result. So it is dependent on how many z at the moment. So how can we count it? So we're going to use a count z. And this count z is going to equal to f -1 because this is our design. Yeah. Now we're going to check all the possible cases. So from 25, we're going to check all the transformations. So from 25, 0, -1. And fi going to equal to fi -1. So this means a going to go to b, b going to go to c, and y going to go to z. Yeah. So it will go to 25. So f24 will go to f25. Yeah, but what about z? It means it will go to f0 and f1. So f0 is going to equal to the count z. And what about f1? Because we've already updated f1 from here, f1 going to equal to f0, but it needed to plus another count of z. So this is the transformation of f1. So let me use an example. Yeah. So for this z, it will directly go to a. So this is why f0 going to go to count z. And for this b, it goes from z and it goes from a. So this is why it's going to plus equal to count z. And from here, it goes from a. So we're going to plus them together. This is why f1 going to plus equal to count z. Now we just need to return the final result. Yeah. It's going to modular the mod. Now let me just submit it to check if it works. Now as you can see, it works and the speed is okay. It is 2 seconds because definitely this is a dynamic programming problem. And the time complexity, it is not ON. It is 10 to the power 5 ON times k. K is 20. K is 25 here. Yeah. So basically this is why it is slow. So it is 25 times 10 to the power 5. So this is going to be the final time complexity. I think that's all about it. Thanks for watching. See you next time.